Alright, in this video I'm going to discuss how to solve systems of equations. And for the purposes of this set of videos, we're going to discuss only linear systems. And these are systems where your equations are in x and y, and sometimes z, and you're looking for an intersection of either lines in this case, or in a three-dimensional case, intersection of planes. Now, first, your equations are going to be in the form like this: ax plus by equals c, and dx plus ey equals f, usually following the standard form of equations of lines. So, let's start with solving one of these, and I'm going to be solving it in blue. And here's our set of equations: 2x minus 3y equals 7, and 5x plus 6y equals 4. Alright, now, to solve this, we're going to use a technique called elimination. Some teachers usually call it the addition method. So to do this, first, look at your equations, line up the variables. Then look and see if one part of an equation is a multiple of another. In this case, the y is here, 6 is a multiple of 3. So we can multiply this top equation by 2, and you'll see what will happen next. So remember to carry this 2 throughout everything. This all turns into, 2 times 2 is 4, 2 times a minus 3 is a minus 6, and 7 times 2 is 14, and then this equation stays the same. And now we can do our elimination. So we add this equation to the first one, and then 14 plus 4 is 18, minus 6 plus 6 is 0, and 4 plus 5 is 9. So we have 9x equals 18, an equation in one variable, and now we can solve it easily, which we'll just have to divide through by 9, and we get the solution: x equals 2. The next step you have to do is to bring this back into one of the original equations and see what our solution for y will be. So I'm going to substitute this into the second equation. 5 times 2 plus 6y equals 4. And then this is 10 plus 6y equals 4. We subtract 10 from both sides. 6y equals 4 minus 10 is minus 6. Divide through by 6. And we get y equals negative 1. So our solution, which will be an ordered pair, is 2, negative 1. Now what this means is these two lines will cross at that point. That's the graphical representation right there. If these two lines were distinct equations and they intersected, they would intersect at one distinct point right there, which represents the solution. In the next video, we'll talk about the addition method and other ways to figure out how to solve these equations.